Welcome. My name is Anne Ellsworthy, and I am the Director of Acute Care Classifications at IHPA. Our team at IHPA has responsibility for the development of the diagnoses and intervention classifications and standards used in admitted and acute care. ICD-10-AM for diseases and health problems, ACHI for interventions, the Australian Coding Standards, and the AR-DRG classification. My background is as a Health Information Manager, and I have been working in the area of classification development for over 15 years. My presentation today is looking at the bigger picture in relation to coding and coded data. IHPA was established as part of the National Health Reform Act in 2011 to contribute to significant reforms for public hospitals. One of its primary functions is to determine their national efficient price. IHPA is also responsible for introducing and updating classifications for activity-based funding. For admitted acute care, the national efficient price is underpinned by ICD-10-AM ACHI ACS and AR-DRGs. ICD-10-AM ACHI ACS is used for all admitted care, while AR-DRGs are principally used for admitted acute care for ABF purposes. There are multiple uses of the classifications, and they include review of the quality of healthcare and patient safety, health service planning, epidemiology and research, benchmarking, private healthcare, and the use case that I am focusing on in this presentation is their role in public hospital funding through ABF. The national efficient price is a major determinant of the level of Commonwealth government funding provided to states and territories for public hospital services. It provides a price signal or benchmark for the efficient cost of providing those public hospital services. The NEP is determined annually through the analysis of public hospital activity and cost data provided by states and territories, and the acute care activity data includes data coded using ICD-10-AM and ACHI. The National Weighted Activity Unit, or NWAU, is a unit of measure of the ABF system underpinned by the activity and cost data that allows comparison of activity across a range of settings. In simple terms, NWAU multiplied by the NEP provides the total cost of a hospital service. AR-DRGs underpin the national efficient price for admitted acute care in helping to determine the Commonwealth contribution to public hospital funding. They are not used for direct reimbursement. States and territories set the volume of services to be provided by local hospital networks via service agreements, and they may choose to pay a price that is higher or lower than the NEP. AR-DRGs, in addition to their role in underpinning the national efficient price for acute care, are also used in funding agreements between private hospitals and insurers. Because of the role AR-DRGs play in underpinning activity-based funding for acute care, it is worth understanding the complexity model within the classification itself. The AR-DRG complexity model is an episode-based model. It assigns an episode clinical complexity score to each admitted acute episode. These scores quantify relative levels of resource utilisation within each adjacent DRG and are used to split adjacent DRGs into DRGs on the basis of resource homogeneity. The process of deriving the complexity score for each episode begins by assigning a diagnosis complexity level, or DCL, to each in-scope ICD-10-AM code reported for the episode. DCLs are integers between 0 and 5 that quantify levels of resource utilisation associated with each diagnosis relative to levels within the adjacent DRG to which that episode belongs. A DCL of 0 indicates that the diagnosis is not associated with higher resource utilisation relative to the average level of that adjacent DRG. but does not mean that the diagnosis is associated with nil resource use. A DCL is derived for each in-scope diagnosis code within each adjacent DRG and informs the complexity score of a particular episode. As the DCL value of a particular diagnosis varies across different adjacent DRGs, i.e., there is not a standard DCL for each ICD-10-AM code, comparisons of specific DCLs for particular ICD-10-AM codes should not be drawn. Neither can assumptions be made about individual DCL values assigned to different codes in the same adjacent DRG. This was borne out in analysis performed by our team to understand what was initially highlighted as a possible anomaly in DCL values assigned to different ICD-10-AM codes in two of the ventilation adjacent DRGs, whereby some comparatively minor conditions such as urinary tract infections had higher DCLs than what might be considered more significant conditions such as sepsis and organ failure. However, analysis of the cost and length of stay profiles of the episodes with sepsis, organ failure, or UTI within these adjacent DRGs demonstrated that episodes containing urinary tract infections did have higher cost and length of stay profiles than those containing sepsis or organ failure alone. While conditions such as UTIs may be considered clinically less significant, the UTI codes had higher DCLs in the adjacent DRGs analysed because they were conditions typically associated with longer stays and overall more costly episodes. This does not mean that urinary tract infections are more significant than sepsis or organ failure, but it indicates that a UTI is more prevalent in longer stays where perhaps there is prolonged urinary catheterization. While sepsis and organ failure may be considered more clinically significant and life-threatening than conditions such as UTIs, they appear to be associated with shorter stays with poorer outcomes that are overall less costly and explains the differences in DCL assignments in those adjacent DRGs. Because the classifications underpin the National Efficient Price and play a role in activity-based funding, there are a number of checks and balances in place to ensure stability. This includes a governance framework that defines development principles for the admitted care classifications. In terms of ICD-10-AM, revisions to ACS 0002 additional diagnoses are aimed at ensuring that only significant conditions are assigned as additional diagnoses in an episode of care, and the standards for ethical conduct in clinical coding aim to support consistency in coding practice and the integrity of coded clinical data. AR-DRGs also have a number of measures in place to ensure stability and include review of the intervention hierarchy, measures in place to ensure stability of DCL weights, review of in-scope ICD-10-AM codes within the complexity model, and measures to ensure stability of complexity splits. Details of the stability measures used in AR-DRG development can be found in the governance framework. Other measures to ensure stability involve the monitoring of activity data and the pricing model itself. The National Efficient Price is based on growth in services expressed as NWOW, and so activity data is monitored quarterly, and any changes to complexity or NWOW growth driven by changes in coded data becomes very evident, and states and territories may then be required to review and explain any such anomalies and to address them as necessary. Additionally, the pricing model and DRG refinement process takes into account changes in coded data over time. For example, if coded data changes and the number of episodes being assigned to a DRG in the higher weighted A split significantly increases, but there is not an accompanying increase in costs, the price may be reduced the following year to reflect that the specific DRG now has cheaper episodes within it. So, in contemplating coding and coded data, it is worth considering the bigger picture and the important role classifications, activity and cost data play in informing the national efficient price and ultimately activity-based funding, and that there are multiple measures in place to ensure that classifications and coded data are current, robust, stable, and reflect real growth and cost. Thank you for listening to my presentation.